Hello, calculus students. We're going to get into the day 2 of limits, and we're going to look at some tougher substitutions. And not all of them will be substitutions. Some of them are just limits that I just have to think it out. And so with that being said, we're going to jump right into number 1 here. And if I look at this limit, I am being asked to find the limit as x approaches 4/3 from the left. So a number smaller than 4/3. Okay. So if I think about that, if I plugged 4/3 in, if I substitute that in, I'm dividing by 0. I don't have a 0 over 0 situation, but I am dividing by 0. And so that lends itself to being something a little special. If I have a constant divided by 0, we tend to look towards infinity. So I have to think about what happens. So I think about 4/3, 1.3 repeating. If I put in 1.3, right? If I put like 1.3 in 7 times 1.3, that's a positive number, right? And it's going to get bigger as I put in 1.33, then 1.33. And then if I put a number like 1.3 into the denominator, I have to think about what's happening there. And so I want you to pause the video and think about what type of value would occur if I put in like a 1.3. So if I put in a number like 1.3, like 3 times 1.3 minus 4, I'm getting negative 0.1. And it's getting, the number is getting smaller and smaller and smaller in the denominator, right? Which ultimately means that my number is approaching either infinity or negative infinity. I know that this is going to be a really small negative number, okay? And so now I understand that this limit will approach negative infinity. So this is one of those that we have to think out. And so if I look at number 3, for example, and I think about plugging in a number larger than 4 but approaches 4. So like I could start at 4.1 and then go 4.01, on and on and on. So I have to think about what happens to this up here, this exponent. And so I know that that exponent begins to approach a positive number. It will always be positive because I'm always plugging in numbers slightly bigger than 4. But it's ultimately approaching 0. So this, just the exponent, is approaching 0 on a positive side. And any number like e, or any number, right, raised to a power of 0 equals 1. So this limit approaches 1. I'm not saying that is going to equal 1. I'm saying it is approaching 1. I want you to take a moment and pause the video and look at number 5. I want you to think about the limit as x approaches negative 1 from the right, a number just bigger than 1. Just bigger than negative 1. I want you to decide in this piecewise function how you would do that. So please pause the video. So I have to decide, am I going to use this part of the piecewise or this part of the piecewise? So if I'm approaching negative 1 from a number greater, and a number greater than negative 1 is like negative 0.9, right? The one that I put the purple dot by is the winner. And so I'm going to think about that, and that I'm going to actually substitute negative 1 into that part because I can, correct? I can do that, and I am going to get 4. Okay, I'm now going to look at a limit that's going to require me to do a little algebraic work. I have to prep this because if I plug in negative 4 immediately, I have an issue because when I plug negative 4 into this denominator, I get 0. So that's a problem. However, I can create a function, it's actually called an extended function, but I can create a function that their graphs look identical, except for one of them has a removable discontinuity and the other one does not. And so I am going to create a new situation by using my factoring skills I learned from teachers prior, right? And I'm going to factor that denominator. And yep, the algebra skills are required for this course, if that is what's going to help you survive calculus. I see now that these divide to 1, and I now can go ahead and use that rule, I can use that rule of substitution. But can I? Because if I do that, so I got to think. My numerator is 1. If I'm approaching -4 from the negative side, so -4.1, what happens to this? And so we have 1 over a negative number, and it's going to be super small. So our limit approaches -infinity. At this time, before I go on to another concept, I would like you to pause the video and try 2, 4, 6, and 8. Do your best, and then start the video again and check your work. So once you've completed this, you should have come back to this video, and I would recommend you pause and look through my work and check yours so that you have time to look at my work. If any of these problems are causing you issues when you are back in class, whether it is virtually or face-to-face, make sure you ask questions about it. And here's that last problem I asked you to work on. I'm going to go through this next problem a little quickly. This is something you should have visited in an Algebra 2 course as well as a pre-calculus course. But we have to talk about what is the behavior of a graph as it approaches a vertical asymptote, which is an infinite discontinuity. And so if I look at this function, I know I can factor it. And I know that I will have a vertical asymptote at x equals 3 and x equals -3. And if I have a true rational function with real coefficients, again, I want to emphasize a rational function, the behavior of the graph, there are two choices. It can, as the graph approaches, it goes up to infinity or -infinity. And so that's what we have to make a decision on. So we have to decide, hey, what's happening? So we need to figure out 4 limits. The behavior of the graph on each side of a vertical asymptote. So these 2 limits are going to determine each side of the vertical asymptote x equals 3. And these 2 limits will determine the behavior of the graph as x approaches, I'm lying to you, -3. I'm going to encourage you to pause the video and see if you can kind of figure that out. What's going on there? Right? What's happening? So if I look at this, what I need to know is x approaches 3 from the right, a number bigger than 3, 3.1, right? 3.01. If I know that the options are infinity or -infinity, I need to know, will my outputs be positive or negative? So I'm not really sitting there going, I need to know that exact number. So I think about if I plug 3.1 into this, my numerator is always positive, but I'm going to do a little color coding for you. I'm going to say this denominator's factor in yellow and the denominator factor in green. That's how I'm going to reference it. And if I plug 3.1 into the yellow factor, it's positive. And if I plug it into the green factor, it's positive. So positive over a positive, this graph is going to positive infinity. If I look at x approaches 3 from the left, that would be 2.9. The numerator is always positive. If I plug 2.9 into the yellow, negative. If I plug it into the green, positive. This guy's going to negative infinity. Try the next two on your own. And there you have it. There are my answers. I'm going to move on. These are some hardcore algebra problems. I am going to work through only two of them, leaving you to work through the other two. These are limits of what we call compound fractions, a fraction within a fraction. So even if students have that idea of what a limit is, it tends to be this algebra piece that's really hard for kids. So we're going to work through that. We know on number 10, I can't plug 0 in. I actually get something that's really wicked. It's 0 over 0. It's an indeterminate. That's something we're going to deal with later in the year. But I can do some algebra. And there's many, many, many different ways that people choose to get rid of this compound fraction situation. What I'm going to do is I'm going to take this numerator and rewrite it using a common denominator. There you go. I went ahead and did that. However, this guy is the one that causes most people headaches because they forget that this entire numerator needs to be negated. So let's rewrite that as one term together. So notice this negative right here. And then I have this all over x. It's not going to be long before this becomes something that I can manage. What's the reciprocal of x? I'm circling it there. I need the reciprocal of x. The reciprocal of x is 1 over x. So I think about this way. I am now just good to go. Don't lose that guy. And I can plug 0 in, and I get negative 1/9. Pause the video and try number 11 on your own. Look at my work if you need to for guidance. All right. Look through my work. See if there's anything that I can help you with, that my work can help you with if you've gotten this wrong. And then again, always ask questions if need be. These can be really complicated with algebra. I have two more, and that's it. And neither one is pretty. So let's think about what we need to do. Though this problem looks a little bit more challenging than the ones before, we can get this to what I call a pretty state pretty quickly. Remember, 4 could be written as 4 over 1, 5 is 5 over 1. Because of the fact we have that going on, what I'm going to choose to do is multiply this expression. Oh, expression. I can only multiply an expression by a value of 1, by the way. So I can be very clever about it. It's not an equation. I can't balance it. So it can only be multiplied by 1. So I am multiplying it by 2x minus 3 over 2x minus 3. And this is going to clean up nicely. So I have the limit as x approaches 3/2 of 4 times 2x minus 3, right? This is we're going to lose that fraction within the fraction right away. Oh, nice. Remember to always do legal math. There's nothing that can divide out to 1 now. I don't have any GCFs going on. You can only do that with GCFs. So I've got to rely on my ability to simplify. Well, that's pretty nice. And once I substitute in, there we go. I'm going to leave you with that. We can do another problem